guys, welcome to my YouTube channel. So we will be going through the book of Introduction to Stats by Sheldon M, and we'll start with the first chapter. First of all, I will tell you all the important points that we're being taught in the first chapter. Like it was a very small chapter, so it do doesn't have any important or any specific point. It just contains generic stuff. So I will let you know that, and then we will follow up with the questions that are provided for each chapter. So we will do the whole book in this series, and let's start with the first chapter. So yeah. The first chapter, Introduction to Statistics, just give a brief about statistics, what it is, what are the types, and all. So yeah, talking about statistics, it basically refers to the analysis that we do regarding any data. For example, the particular word statistics is derived when people from Western Europe were trying to derive all the data for their state. So they collected the data for the particular state in a informed manner. They collected the data for plague, the deaths caused by plague, the burials, etc. So that's where the term stats is derived from. And it is of two types. First is descriptive, and the second one is inferential. So talking about descriptive statistics, so descriptive statistics is nothing but how you describe your data. So it's related to how you describe your data. It could be like if you describe through a pie chart, or if you describe your data through histograms, line charts, etc. So all the information that you can derive from data, or you can like draw or basically represent the information through diagrams, pictures, and data is comes under the descriptive statistics part. And what comes under the inferential statistics? So basically, inferential statistics is referred to making some assumption or making a guess of what would be applicable for the whole population. So whenever we are making a prediction for a particular population, or like what will happen to a particular population if we are given a particular sample, then we use inferential statistics. So inferential statistics is that branch which helps us to make prediction on the large scale population and is basically inference. So you can learn from the word in inferential. We are generally inferring that we can do this from that particular data. So these are the two types of statistics that is discussed. And also the third point, which is the main crux of this whole chapter, that in statistics, when we take the data, that is, when we consider data for making a bold assumption on the whole population. So, if we consider this as a whole population, a small part of it would be the sample. And what is represented in the book is that through this sample, what this sample should be, it should be representative of the population. Like we should strong sample because the stronger the sample, the better the prediction of the whole population, right? So we should always take a representative sample. And how can we take this sample strong? Or like, what are the factors that could make this representation sample strong for predicting the whole population or predicting for the large scale masses? So the first thing is that random selection is the utmost important point for selecting data of sample. So it should be completely random. So for example, if we are predicting for 400 students and we have a sample size of 100 students, like for example, we are predicting how many students are present in the class for 400 student sample size, and we have only 100 students data, that how many are present and how many are absent. So this 100 number should be completely random. Yeah, it should be completely random. And why I'm telling so? Because if we don't take completely random, then it may be the case. For example, you may consider a scenario that Yeah, so there may be a scenario that, for example, there are four sections A, B, C, D, and all of this constitute the sample size of 400, and each section has 100 students. Let's assume. Now, if we do not take completely random, and I take completely all the students from section C, it may be that section C students don't come to the school and they generally don't have any classes. For example, all the teachers for the class of section C are on leave, so they don't have any classes for that month. And the percentage of attendance or percentage of students coming to the class is zero. But for A, B, and D, the teachers are coming regularly and they are having regular classes. So their percentages are 75%, 45%, and 80% for attending the classes. Like this is the percentage of students present. So if we take 100 students and by chance if we take all the students from C class, then it would give a very wrong factor and it would be not representative of the population. So that's why to minimize the errors, we should take more random data. And it is quite paradoxical, right? That how could random data be more representative of the population? But this is how stats work. And the more the random the data, the more representative it is. Because if we take now we have the like freedom to take random data from all of these classes. And now I will not take all the students from C. So I will take 20 students from A, 30 students from B, 20 students from C, 20, and 20 students from, sorry, and 30 students from D. So now these are the 100 students. Now, after selecting 20 students of A, I have a probability. After selecting of 30, I have a probability. So, and after selecting 30 students from D, I have another probability, which would be, of course, very much true factor as compared to the 0%. For example, if we get a percentage of 60, then we are good to go and our prediction is close to accurate. So that's why the point mentioned in this crux was that the random data should be representative of the population, is representative like of the population. And we should always consider random data for choosing our sample. There are some problems which we will do one by one. Figure out how much you can love and